continue straight from previous video where we have calculated the external pressure. So this is the wall. We calculated the external pressure 133 pascals. That we calculated external pressure 133 pascals, and we also calculated minus 826 pascals in the last video. That we calculated internal pressures minus 823 pascals. So is minus is going in this direction and the plus is going in this direction. So in this scenario, what we done that for internal pressures, we assume this door, these 4 windows and door is open, but all other windows and the doors are closed. But we found that there is a leakage in the building which is 0.1%. So we take the ratio of area of this opening divided by the area of the opening for the whole building except this one. So that's we found 0.91 that we found 0.91, and then we take the ratio. So now that's net pressures we like to calculate, which is 133 pascals. 133 pascals going in this direction, and plus, please note there is a minus here, but in the combinations we are always looking for the direction. So therefore it's plus 826 pascals. So that become 2156 pascals inwards, and then that become 2.16 kilopascals. Now I have some notes that can help to understand some of the concept. Here for westerly wind, that we have it in the example. We have westerly wind that is given in the example. The wind is blowing normal to the wall with no opening. So there is no opening and is blowing on here. The only window is the stained glass window, and it will be designed to prevent the breakage. So only window on this surface is a stained glass window. It will probably have a screen to prevent damage by vandals, which would also function as a debris screen. So we have some metal protecting screen or something to protect that glass on that one, because that is this wind is directly hitting that glass. So design will assume that it is not an opening. So we are assuming that this is not an opening for our case. Now the second case that we like to say, the building has potential opening that are the doors and windows in the side walls and leeward walls. So we can see that we have doors on the east wall, so that is leeward walls. We have a total area of there is double doors, which is 1 point. So we can have this opening, or we can have this side. So we can assume one of these is opening. There is no mention of a roof vent in the design brief. So there is no any opening on the roof in the questions. Under ordinary operational circumstances, all of the windows and doors would be shut during the strong winds to protect the content of the church from the wind-borne rain or sands. Right? So in general case, we assume that they are all closed, sealed buildings. However, at the strength limit states, it seems reasonable to assume that one door or window may be damaged or come open. So we can say that one should open. We need to consider the worst conditions for the design. That would consider as the largest opening. For westerly wind, the largest opening can be the side wall or leeward wall. So we can consider that we can find the area of the opening here, area of the opening here. We can find the area of opening here, area of opening here, and we can find which one create the most severe one. So by looking here, this opening on the side walls would consider the most severe effect. So therefore we are considering the opening here. All other surface has a closed windows and door. So for the design for the internal pressure, must examine 3 scenarios. Well, no opening. So all the windows and doors are closed. There is no opening. That has a CPI value of minus 0.30, table 5.1a, page number 30. So we have 2 tables. Table 5.1a, that is when there is no opening, and there is a table 5.1b when there is an opening on one of this wall. So as first assumption saying that we have no opening, like whole building is considered as a sealed building. There is no any leakage and there is no opening. So in that case we can calculate the CPI value, that is that is from table 5.18, we can so all walls are permeable. We consider that walls are permeable, like a 0.1% permeability that we assume in the last videos. So therefore we have a permeable building, 0.1% assumed. So in that case we need to use minus 0.3 and 0.0, whichever is the more severe for combining the forces. So we need to choose one of this one which creates the worst effect. So therefore we have minus 0.30 coming from table 5.1a, because all walls are permeable. Another one is opening on the side walls. So let's assume that these windows or the doors are broken and they have a opening when the severe winds are coming. So in that case we can consider that opening on the side walls. So we need to find the largest opening on the side walls. As you can see, the wind is coming from this side, so the opening on side walls, that will allow us to use these values. And in the previous video we calculated this ratio, which is 4.4. so that's allow us to calculate give us minus 0.65 for CPE for the side walls. We checked in the previous video, which was minus 0.65 from table 5.c on page number 34. I can show it here. On table 5.c we have CPE values, and we take it the largest negative value, minus 0.65 as a CPE, because in here in these tables we have CPI equal to CPE. So that is minus 0.65. Now opening on leeward walls, let's assume that we have these doors and windows are closed, but let's say we have a broken windows or broken doors on the leeward wall. So that is the opening on leeward walls. In that case we need to go back in the table 5.1b on page number 31, and we need to consider the opening on leeward walls, and we can see that we have a ratio 4.4 that will allow us CPI value is equal to CPE. So we need to check the CPE value for leeward walls. From table 5.2b, page number 34, we have a table 5.2b on page number 34. We have a leeward walls. In that leeward walls we have a gables, and all the values like a roof pitch for all the values, or you can calculate the roof pitch 23, like calculating the roof pitch these angles, like you can take the half of 23 and the height of this one, which is 7.8, take away 2.7, so you can find that angle. That angle is actually 23 degree. You can find D on B, which is 1.24 is a D, parallel to this one is D, perpendicular to this one is a B, so 1.04. so that has a D on B value, which is 1.0, so is equal to 1, so that has a minus 0.5. that is we take it from here, because we have wind direction theta equal to 90 in figure 2.5. so we have this scenario where theta equal to 90. We have this wind is coming, so you can imagine to rotate this one. If I rotate this one, so that's the wind, and that's the structures that we are comparing. So we have a theta equal to 19, gable roof. We can say these all are gable roof, and these are the hip roofs where you have these four scenarios. And then all the values of roof pitch, and we are having a D on B ratio 1, which is minus 0.5 that we calculated, that we got minus 0.5 here. Now the most positive internal pressure for westerly wind is given as CPI equal to 1. So you can check all these three cases here. One is this one is here, and one is here. We need to find the most positive value, most severe one. So in here we have the most severe one is 0. Okay, so CPI equal to 0, and most negative internal pressures that we can compare here, minus 3, minus 0.65 and minus 0.5. Among this one we can find that minus 0.65 has a severe effect, so we are taking minus 0.65 in the calculation. So that is just a supporting values for the last video that we calculated CPI in the last video. in last video we calculated the CPI value minus 0.6 minus 0.65, CPI largest negative value minus 0.65. That's how we obtain minus 0.65. Thank you.